We have here with us Mr. Mark Schoennagel. He's the lead evangelist from Unity Technologies, and today he's going to be talking about Unity architecture.
Thank you very much. Excellent pronunciation on my name. No one ever gets it that right. Cool. Yeah, so that's me. So I'm Mark. You may have seen me in a couple other presentations. So we're going to talk a little bit about architecture today and some of the neat new uses that Unity is being used for architecture. So I'm just going to play a really quick little video. It's just about 1.5 minutes long. It's just music. Ugh. That didn't look right. It's okay, it's just music. It's really okay, it's almost over. That was it, it was actually over. Honestly, it's not important. Yeah, that's what I was trying to do earlier. It's not important. Really, it's okay. No worries at all. Ooh, here, we can do this. There we go. That's easy. I'm not doing that anymore. All right. I don't even know what some of this has to do with architecture, so that's all right. Anyway, all right, cool. So there we go. A little bit of eye candy. So, architecture's changing. You know, for a long time, people were drawing blueprints on draft paper, right? And then we started using things like AutoCAD, computer-aided design, and that went on for a number of years. People, using computers, but still working primarily two-dimensionally. Then we started to be able to do some rough 3D things, and now we're really starting to get into the ability to do ray trace renderings, and that's actually been going on for a while too, but now we're at the real-time revolution, right? Now people are starting to be able to take their models, bring them into Unity, and start to make them look really, really sexy for their clients. So we have to change the way architects think. It's a really big revolution that's taking place right now. So there's new platforms, things like augmented reality, virtual reality, being able to put on a HoloLens, go on site, see the plumbing behind a wall, see the electricity behind the wall, see the power lines behind a wall, being able to do things with tablets like I'm going to show you here in a minute, cloud-based solutions, having not only the cloud store your data, which is no big deal, but actually process that data, hold tremendous amounts of data for large skyscrapers, things like that, and then global collaboration, being able to work with teams across the world. We actually have a new Unity office opening in London, which was designed by Gensler, and they actually collaborated across many different offices around the world to get that final piece done. So that's the kind of stuff that's happening every day, and Unity is being more and more a part of that. So some interesting things that we saw. A couple weeks ago was a big conference in Las Vegas called Autodesk University, and I was there. It was really wonderful. No joke. I can't tell you how many people came up to me and said the news that Unity had an official collaboration with Autodesk was the news of the show. It was a really big deal. Autodesk has normally been a very closed company to work with. They want to do everything. They kind of realize that they're not going to be able to catch up to Unity with the tools that we have, so why not just work with Unity? So we have this collaboration, which I'm going to talk more about in a little bit. But coming from that conference, we learned some interesting statistics. 81% of the companies out there are planning to spend a lot more in technology this year than they did last year, and that's only going to continue to grow. Collaboration was the #1 trend at Autodesk University, how these companies are going to work together. You don't have to be the architect to do the 3D visualization in real time. You could be a game company that gets contracted out by a local architect, and you guys work collaboratively together to make that stuff possible. And an interesting thing from ConstructionDrive.com, which is a leading construction magazine, is that XR was the 8th most popular trend. One of the trends was, how was America going to work with Donald Trump as president? So, I guess that's a good trend too, but stupid trend. Anyway, whatever. This was interesting. So a few years ago, Taylor Koop who works at Mortensen, was one of the very first adopters of using Unity for architecture. Not only 360 video, but also being able to do real-time visualizations. And this was around Unity version 3.x, so we didn't have the HDRP, the high-definition render pipeline. The visuals weren't nearly as good, but they were real-time. You were able to navigate those environments in real time and use 360 video to supplement that. They've been behind that since day one, and the stuff that they're doing now is really tremendous. There's a great case study on unity.com, so it's unity.com case study. You can take a picture if you're interested. It's just a blog post, but it really talks about how they're using Unity technology to make their architecture look a lot better. And again, they were one of the very early adopters. So a $450 billion problem is what we believe is out there in the world. That's what Autodesk believes is out there. Money that's literally wasted from just not using tools properly. And it's funny because I actually have a real world story that goes along with this. I did a remodel of my house recently, remodeled the kitchen. And I had to put in new lighting and new cabinets. And my job has me on the road literally like 200 nights a year. So I wasn't there to supervise a lot of stuff. I had the blueprints that the architect came up with for the lighting design. It was 6 canned lights in the ceiling. Well, they weren't spaced apart the way the electrician thought they should be. So the electrician decided to move them a little bit more, a little spread out, because that's how he thought it should look. Well, what he didn't realize was the cabinets are going to go there. So now I've got a cabinet with the light right next to it, which looks really, really stupid. Because he didn't look at the drawings. He didn't care about my drawings. He didn't have a cool, which is my fault because I'm in this technology, I should have done it. So he screwed up the house. So they had to come back. Not only did they have to cut my ceiling and move the things, the drywall people had to come out, make the drywall look pretty again, which was a nightmare because that put dust all over my room. And that was just in my house, and that cost about $4,000 or $5,000. So this number seems true to me because if I think of like a skyscraper, and if you're not on top of those things, those kind of problems happen, and they're very, very expensive. So $450 billion is what we believe, or what Autodesk believes, is lost money from companies making mistakes, not using their tools effectively, which is a pretty big number. So I'm going to show you some cool stuff today that hopefully can solve some of those problems, and maybe if I would use my own tools and stuff, I would save myself some money. But anyway, real time's the future. If I'd had an augmented reality tablet and showed him what the final design was going to look like, he wouldn't have made that dumb decision. And of course, I wasn't in town, so I missed it. That brings us to Revit. So Revit is the de facto tool out there that's being used for architects. AutoCAD is still a big tool. Both of them are made by Autodesk, but Revit has really kind of taken over. It's a very complex program that's designed to handle extremely large data sets. So Revit looks a little something like this. If you're an architect, you feel right at home with this. If you're a game developer, you're, whew, what's that? We don't care what this is. We just need to get the data out of that, right? Well, Revit has something called BIM. BIM stands for Building Information Management. It basically keeps track of every little thing that goes on in a building. It's actually to the point where if you're an architect, or if you're designing, say, a 20-story building and you're using Revit, every single light switch has BIM information on it. It knows how many times that switch can work before it has to be replaced. So you know that 60 years into your building life, you've got to change all the electrical switches. Who makes the refrigerator? Who makes the ice machine? All of these things have information provided by the manufacturer that goes into Revit. So Revit can then estimate your building costs, not only while it's being built, but how much it costs to maintain it. It's a crazy amount of data that is stuck in these models. So when you export your data out of Revit, there's so much stuff. And those light switches are all models. They're all real 3D models. Could you imagine loading 10,000 light switches into Unity, how that would slow things down and how unnecessary that would be? Because it's just a light switch. You just make it out of a texture map, right? So we really need some really impressive and powerful tools to make it so those two things work together. So I can filter out what I don't need, and I can only keep what I need. If we keep kind of going through some of these slides, this is a small Revit example. This is, what, a 4-story building, some escalators. The life expectancy of the escalators is in there. How often they need to come and maintain them is all in there. Then you start to get into the plumbing. all the ductwork, all the electrical conduits, all that stuff. And you can do all your building estimation of the cost of this. How much is that going to cost to build a 100-story building, all the electrical cables and things you need to run? If you have the BIM model, it's easy for an electrician to make that estimation. So it's really important for not just building, it's important for maintaining, it's important for visualization. It's really important to how we're going to optimize that data, how we're going to get it out of there. And then you start looking at buildings like this. This is the Shanghai Tower. It's going to be the second highest building in the world. All that is contained into one BIM database. Can you imagine how much data that is? When you think of just like the floor, there's carpet. Underneath the carpet, you have usually some padding. Underneath that, there might be a layer of wood. I don't know. Then there's concrete underneath that. So you have 3 or 4 or 5 different materials that make up the floor. If you bring that into Unity, there's just going to be Z fighting, right? You're going to have polygons clipping polygons. It's going to look terrible. So you need to be able to filter all that out. But you can't just throw that data away. So again, we need these intelligent tools to make sure that all that works nicely and that we get the best optimized model. So we have broken workflows. So let's just talk about some of those. First of all, before, because we're solving this problem, getting to Revit was very, very difficult. You were in Revit, you exported FBX. FBX is not a very good format for exporting a 100-story building with all the light switches, with all the cabling, with all the carpet, with all the walls, with all everything, right? From Revit, you'd then go into 3ds Max, and then you'd clean up the model, which is ridiculous. Time-consuming, a horrible nightmare of a process on anything bigger than maybe my kitchen. As stuff gets bigger, it's more complex, it's more to clean up. And then the worst part is if the architect made a change in the Revit model, you had to start from scratch. There's no round-trip workflows. There's no way to preserve the data, the stuff that you've already done. So it was Revit to FBX, to 3D Studio Max, back to FBX, to then get that into Unity. A one-way street with no way to go back. Yeah, no bidirectional. Z fighting, so many layers that I just mentioned. There's the wall, there's the wallpaper, there's all this stuff has to be represented in a BIM model, which we just don't care about in Unity. Yeah, so BIM work great with a 2-story buildings, but most BIM models are mid-rises. You're not going to use Revit to build, a bedroom. You're going to use it to build a big project. Yeah, and so it's good for design, but not for visualization. You don't know who installed it. You don't know who made it. With BIM, you know the name. You can put the name of the contractor who installed that device, so that if something changes, you can always go back to them. All that stuff is preserved in the BIM database. So there are some solutions now. We have several. The one that we made a partnership with about a year ago, which was actually for automotive and CAD, I don't know if you saw my talk earlier, is using Pixies. And about a month ago, Pixies announced support for Revit. And it's not just an importer like the CAD model is. It's much different than that. It actually has a rule engine which allows you to say, I mean, I'm not going to show it today, but it allows you to really be specific about what you're importing, what you're not importing, per object, per layer. It gets very, very deep. So I invite you to try that. You can download it today. And it does some nice things. First, it exports the IFC model, which is an international file format that's designed specifically for architecture. These files are huge, they're highly optimized, and being able to work with the IFC data and not the FBX data is a huge win for architects. So it just makes everybody's life easier. As it says there, they're very heavy. It's the complete BIM database. You see all that as a component list inside of Unity. So if you click on the refrigerator, it'll show you all the BIM data. But you can then decide, you know what, I don't need all this stuff. I only want these certain things through the rule engine. So yeah, so you can optimize what you don't need. You can eliminate the need for 3ds Max. It will do your UVs and all that stuff, so you can apply textures. And you can focus on the app that you're building, either a tablet app or something on your PC, whatever, and not have to worry about the data. And there's actually a special bundle pricing coming soon for Pixies, which includes the CAD importer for you doing stuff like automotive or industrial, plus the Revit tools. And there's going to be special India pricing involved or available too. And that's going to be announced a little bit later this month. Sorry, I don't have that information for you today. Another solution that's available, and they actually did a presentation here earlier, is Tritify. And this is a cloud-based solution. So what you do there is you upload your BIM data, you upload your Revit model. It does a lot of processing, and it just gives you a really nice, clean model that you can load into Unity and process and continue on with your work. It's a really powerful tool. And then there's our collaboration with Autodesk. So this is a true source code collaboration, which is incredible. Autodesk generally doesn't like to work like that. So it allows you to go from Revit to Unity and then back over again. So if you make changes to your Revit model, they'll update inside of Unity. The only bummer about this is that it's not going to be around until 2019.2. So we got a little bit of time to wait. So totally use Tritify, totally use Pixies, and even after our partnership, or after those tools are released, continue to use them because they're really good products. But we are working with Autodesk on a source code level. So they have our source, we have their source, and this really great collaboration is happening. And it's not just for Revit, it's for Max, it's for Maya, it's for Shotgun, it's going to be all the Autodesk products. Well, all the ones that are relevant, at least. And again, that's going to be as a preview in 2019.2, and it'll be fully shipping as a final version or a release version in 2019.3. And it's also going to have full support for the Autodesk Material Library and the Revit materials, which are very different than materials that we're used to working with in games. There are a lot of procedural materials. Generally, Revit materials don't play well with anybody, but they will play nicely with Unity and only Unity, which is going to be great. And again, an industry-first source code collaboration with them. So really great stuff. So on the PowerPoint side of things, key takeaways, Autodesk and Unity, we're working together. It's a good thing. It's a fantastic thing. I used to work for a company called Softimage for a long time, and they made a competitor to Max and Maya. And every year we would have to fight the FBX file format because every year Autodesk would change it. But why, I don't know. But it was always a struggle to maintain and keep up with FBX, and that's not near the nightmare. I should say nightmare, but it doesn't have near the data that BIM does. So having a real collaboration is incredible. I actually worked at Autodesk for 7 years as part of that, so kind of got the understanding of how all the Autodesk stuff works. And it's only the beginning. We're just going to continue this collaboration and just make sure that for you all, it's always going to be the best workflow for Max, for Maya, for Revit, and for all these nice VRED, for all these nice Autodesk products. So anyway, that's that. So I'm going to show you some stuff in Unity because I don't really care for PowerPoint all that much, but sometimes I have to use it. Oh, look, Slack. Anyway, cool. All right, so I'm going to show you a neat little demo here. So this is our London office. Actually, you know what? Let me show you the London office first. Let's just go maximize on play. And let me give you a tour of our brand new, this opened literally 2 weeks ago. Our office in the UK has always been in Brighton, and now we have an office in London as well. And there's some really neat stuff going on here. So first, I can just walk around and get a feel for the office. This is using HDRP, which is why it looks so pretty. So many architects came up to me at Autodesk University and were like, why don't my models look pretty like that? Are you using HDRP? Nope. Oh, let's use HDRP. Stuff just looks pretty right off the bat with HDRP, right? We made this all interactive. This is the kind of stuff, first, you can't get this kind of look in an Autodesk product. I mean, you can do it in Max, you can do it in Maya, but it's not going to be real time. And it's certainly not going to be interactive like this. So I can walk up to this TV, I can turn on this, press the C key, and it's going to play the Unity demo reel. So it's just embedding a video, super simple. We're used to all that stuff. Just drag and drop it on there. Look at the reflections that are going on the television. We're actually using a new type of reflection probe, say that 10 times fast, which I'll show you in just a minute. Having doors automatically open makes your scene very inviting. Hey, come on in, check it out, there's our conference room. And if I go here, I can turn the lights on and off. Look at that beautiful baked lighting, very pretty. And we can go back outside here, and look, there's birds out there. In Autodesk, you don't really get birds in Revit. But they just add something, It really, if you can show your client something like this, that's cool. And you know what if I don't like this floor? Well, shoot, I can just change the floor just with a keyboard, or I can use a joystick. Super simple. We're used to all of this stuff, right? Architects are not, nor are their customers. If you're an architect and you give your client something like this, and the competitor gives you some drawings, who do you think is going to win the bid? Of course, the person that delivered this. So embrace this technology. Go to architecture firms and say, hey, look, I can do this kind of stuff for you. If we go into this room, we got some other neat stuff going on here. We have the BIM data. All of this stuff is the actual real BIM data. Who made that ductwork? Who fabricated it? Who installed it? What is the URL for the company that installed it? And there could be a crazy amount of other data that we decided not to show, but using some of these rules, we're able to achieve exactly what we want. What type of wall is in there? The telephone number. Who do you call when that thing needs to be replaced? Once a building is built, that stuff is normally lost, right? Someone punches a hole in your wall, try to match that tile, try to match that fabric. If you have all this data in a database, it's really simple. And if you have it something like this, it's even better. Let's see, we can make it go to nighttime. Let's make it go to nighttime mode. Nighttime mode, there we go. And now it's nice and dark and much more moody. This is cool. This is the actual artwork that's in the Unity office in London. A bunch of dominoes. Weird. I haven't been to the office yet, but apparently it's pretty cool. And even subtle details. There's a little asset called rain on the asset store that gives us rain on the windows. Look at that. Isn't that cool? Little subtle touches like that just make this scene more believable, and that's literally almost a drag and drop. You download the asset, you plug it in, and boom, there you go. So, some cool stuff there. So I'm gonna go ahead and stop this really quick. Is there anything else I want to show you in there? Oh, yeah, let's do one more thing. There's some cool emissive light going on the PlayStation VR headset, so you'll see that there's some blue glows going on the table. Just little bits more of believable stuff. So I'm gonna go ahead and stop this, and let's go and turn off maximize. Let me just kind of dissect the scene a little bit for you. All right, so turn off maximize, and we're gonna go back to play mode, but I'm gonna swap over into scene view and just kind of drive around a little bit while this thing's still running. So, all right, so first of all, there's our birds. Asset store package, $5. There's some birds, great, cool. Let's go back. Wait, where's my building? I lost my building. Oh, there it is. Whee, I flew a little too far. See, who cares what it looks like on the outside? The client's never gonna go out there. There's all our reflection probes. Well, speaking of reflection probes, there is, where's my, here, let's go over here. We'll see this best. All right. You're probably thinking I'm using screen space reflection. If you know what screen space reflection probes are, basically it calculates what's visible on the scene, in the screen, in the game view, everything else is called, and it shows you those reflections. If this was a screen space reflection probe, so this right here, this reflection is caused by this window outside there where the birds are. With screen space probes, if I went like that, that would disappear. We would lose that reflection because if it's not visible in the screen, it's not going to cause that reflection. So now what we have is something called this planar reflection probe. And if I zoom out a little bit, that's a little too much. Where is my planar probe? It is, oh, there it is, planar reflection. Yeah, there we go. So with the planar probe, this is great for doing mirrors. This is showing me what it's reflecting at that exact moment. So as I move around, you should see it. Oh, we'll see it there update. You'll see it there update. That's what it's reflecting. That's the actual reflection probe right there. So as we move around, we can see exactly what it would be reflecting. And I can move this up. I can move that down. It's just a nice new little trick we have for doing accurate reflections. If we go to our lights, crazy amount of lights. Look at all those lights. We've got our temperature settings. Architects and designers love all that kind of stuff. We can see our reflection probes. There we have our planar reflection probe right there. And even emissive materials. So there's the PlayStation VR causing that little bit of blue that's on there. It's just a checkbox. Just turn it on. Makes things look a lot prettier. Let's see. What else did I want to show you on here? Let's make a few changes. So let's go here to our chair. Architects love this kind of stuff. Clients love this stuff. Hey, you know what? That chair looks ugly. If you rendered this, if this was a pure rendering and the client didn't like the color of that chair or the fabric style, you'd have to redo it all. You'd have to go into Max, change the color, do another rendering. You know, because it's Unity, it's all just real-time stuff. So I could just go here and say, you know what? I want the chair to be a bit more red. This is simple stuff for us, right? This blows architects' mind. They're just not used to working real time like this. So go to your architect, show them your Unity skills, and get yourself a good job. It's cool. There's a lot of good stuff out there. What else did I have on here I wanted to show? Doors opening, closing. Oh, the glass, right? The glass is the coolest. All right. Normally, when you have, actually, let's go into game view. When you have glass that has that type of a bevel on it, you're used to seeing crazy amount of noise. It's a little noisy on these screens because it's like an individual pixel projector, right? On my screen, there's no jitter at all. So this was actually a lot of work by our shader team to come up with a new, just update the lit shader to support this type of stuff. This is actually just a texture map, a normal map on there. So watch this. If I go back to scene view, and let's just zoom in a little bit on here. If I go and select that guy, and we take a look, we now have this transparency slider. So I can change the index of refraction. I can change the thickness if I want. And all this stuff is just living on the normal map. So there's no geometry here. I'm not dealing with geometry. Oops. Whoa, what did I do? Oh, I framed the birds. Sorry. I'm going to have to kind of hunch down a little bit. Where'd that glass go? I took the normal map off. There we go. So there's the glass. And if we take the other map, if we get rid of the height map, oh no, sorry, this map here. Oh, geez, I lost it. Well, whatever. You can make the glass become completely transparent. So it's just a texture map on there. It's just the normal map that allowed us to get that really nice bump on there. And then just move that little slider, and there's no shimmering, there's no crazy noise, which is always a bummer. So anyway, that's a look at our office. There's all kinds of other stuff going on in here, but that's kind of the highlights I wanted to show you. So I'm going to go ahead and stop this. And if we could, I want to switch gears and show you a cool little tablet experience that we have. So Would it be easier for me to just unplug and unplug, or can you guys pipe that in? Why don't I just do it the easy way and unplug and replug? Good for you guys? All right, cool. Don't mind me. All right, so we should have, yikes. Yikes. All right, well, that's probably my cruddy little connector here. All right, well, sorry about what you're seeing there. You got a little bit of jitter. But, all right, let me show you what I got going here. I got a bunch of plans. I got a bunch of blueprints, right? A whole bunch of blueprints. So these were provided by our friends at this company called Bevel, and we worked together with them and LinkedIn to create this dynamic set of blueprints. To create this building is a ton of work, right? To do what I'm going to show you is not much work at all. So again, taking this to your customer blows their mind, right? So here's a building. I'm just going to take a look at it. I touched the thing here, and this is now the full-scale representation of the building. This one isn't quite so cool because this is designed for going to the actual site where the building is, putting the blueprint down, scanning it, and now you can see, if you're in the area where they're going to build this, you would see this building. So this isn't the best one, so I'm just going to turn the page. Ooh, I crumpled them. Turn the page. We'll take a look at this one. Look how fast it locked on. I wasn't even know what the page turned, and we're locked on, and now I can see, and sorry for the jittering, it's really nice and beautiful on my side, but there's our building. I can start to turn things on, like, you know what, let's see the plants. Hey, look, there's some shrubbery. Cool stuff. All the stuff here on the left, this is all the BIM data. If I touch this wall, if I touch various parts of it, we can see that update. There's also photospheres. If I turn the photospheres on, I can touch one of these little balls, and it shows me what it would look like if I was actually in that environment. So you go to a customer, you show them this kind of stuff, incredible, right? Like, it's such a different experience, and it's not a lot of work. If you know Unity, this stuff is pretty straightforward. So let's flip a couple other pages here. There's like 20 pages they made or so. It's this one. So touch that, and there's our next one. So same thing. Let's turn off the photospheres. Turn off. There we go. And so nicely locked on. It's just using Vuforia. They're able to crank these out, 2 or 3 of these a day without a whole lot of work. And turning things on and off, rooms, the floor. If I touch things, you can see the BIM data here on the left. And I could keep on scrolling around. Look, as soon as I flip it, I've got too much weight. Oh no, I've lost my plans. Use my leg. Check that out. Isn't that crazy? Just sit there with a client and flip through a bunch of blueprints. Like, it's magic. It's absolutely magic. So anyway, that's some of the cool stuff that we're doing. I'm going to put this down because my plans are sliding off the table. I'm going to lug these across the world. Anyway, cool stuff. So that's a little bit what Unity is doing for architecture, AEC. Yeah, anyone have any questions? Silence, good stuff, happy stuff. All right, go talk to your architects and show them what you've seen today, or talk about what you've seen today, and yeah, go talk to architects. So let me know if you have any questions. Cool, well then we're done. Thank you all very much.
Thank you so much, Mark.
My pleasure.